Hello students, welcome back to the channel. Now this video onward we will discuss the topic current electricity. So let's start. Student, for this concept first we will deal with current. You know what is current? It is the rate of flow of charge. Charge is indicated by Q. Rate means in physics when any physical quantity is divided by time, that indicates the rate. So what is current? Current is indicated by I. Rate of flow of charge. Charge is indicated by Q. When I divide it with time, it indicates rate of flow of charge. Now you know SI unit of charge is coulomb, while that of time is second. So based on that, the SI unit of current is coulomb per second. But this concept was given by Andrew Ampere, so we consider in his honor this unit as ampere, which is indicated by capital A. Weak current is indicated by milliampere or ampere. So milliampere and microampere, they indicate the weak current. So how they are related? 1 milliampere is 10 raised to minus 3 ampere. So how the microampere is connected? So your 1 microampere is 10 raised to minus 6 ampere. But when you talk about the SI unit, the SI unit is ampere, actually equivalent to coulomb per second, and the equation is I equals to Q upon T. The next quantity which we'll discuss is potential difference. Potential difference is indicated by capital V. What it is? It is the work done per unit charge. Okay. Work done per unit charge in carrying the positive test charge from one point to another. Suppose A point. From A point to B point, when you just move the charge, test charge, whatever is the work done to carry that charge will indicate the potential difference. You know, work is indicated by W, charge is indicated by Q. So what is your potential difference? It will be W by Q, work done per unit charge. You know, SI unit of work is joules. This is coulomb. So SI unit of potential difference is joules per coulomb. But in the honor of the scientist Volta, we consider it as volt. So what is the SI unit of potential difference? Volt. Volt is also indicated by capital V. So potential difference itself is indicated by capital V. Its SI unit is also indicated by capital V. This thing you have to keep in mind. Now let's discuss the concept of resistance. Resistance is indicated by capital R. When you consider any of the, suppose this is my conductor, when you consider any of the electric circuit, this indicate positive terminal, this indicate negative. So usually when we consider we indicate the flow of charge from positive to negative. Why? Can you guess? This indicates the test positive charge. But actual flow of electrons are exactly reverse of this. Actually flow of electron is in this way. So because of that, the positive charge will move in the reverse direction. These wires are made up of metals. They have their own electrons. This conductor is also metallic one. It has its own electrons. So when you deal with any of this circuit, there are two kinds of electrons. Electrons of the wire and electrons of the conductor. These electrons, when they enter till this point, they are free to move. But at this junction, they are obstructed by the electrons of this conductor. So obstruction provided by these electrons indicate the resistance. Understood? So the obstruction provided by these electrons of conductor indicate the resistance of the conductor. If this obstruction is very strong, then they won't allow these electrons to enter. So you can say resistance is high, but electrons cannot pass through, so conduction is low. Got it? So the wire with high resistance indicate poor conduction. But on the opposite way, if these are not too strong, their strength is low, then these electrons will get a place. Easily they can pass, overcome the obstruction provided by these electrons, easily can pass through. So they are good conductors. Got it? So conduction and resistance, they are the opposite concept. If the resistance is high, conduction will be low. Same way, if the resistance is low, conduction is very high. Good. So good conductors always have low resistance, while poor conductors always have high resistance. Now student, let's discuss what the German scientist George Ohm has observed. He has observed that the current passing through the conductor or any of the wire is directly proportional to the potential difference across it, and provided the physical conditions and temperature remains the same or constant. Now in maths you have done, if x is proportional to y, to remove this proportionality sign and convert into an equation, you have to insert a constant. And in maths, generally we insert this constant as k. So what the Ohm has observed, that current, this is what current passing through the conductor, V is the potential difference. Again, he has made a law which is known as Ohm's Law. So what the Ohm's Law is, students? Current passing through or flowing through the conductor is directly proportional to the potential difference across the ends of the conductor, provided physical conditions and temperature remains the same. So what he has observed, that V by I ratio is always constant. Here in max we will consider K as a constant. What he has observed that this constant is numerically will be approximately equal to the resistance. So he has considered this V by I ratio constant that is equal to resistance. So V equals to IR indicates your Ohm's equation. This is your Ohm's equation. With this, mathematically you can easily calculate the value of resistance. So what is Ohm's law? Current flowing through the conductor is directly proportional to the potential difference across the ends of the conductor provided physical conditions and temperature remains the same. And V equals to IR indicate Ohm's equation. Students, thanks for watching this video. Hope you have understood whatever concept I have taken in this video. If you like the video, share and subscribe. Thank you.